Alright, continuing with where we left off, so this is section 7.4 on solving equations using logarithms. So the key thing to notice here is that when you have the same base, which we do right here, and we do also in number 11, the log base 2 of 4n equals the log base 2 of 3n plus 2. That means this thing and this thing have to be equivalent. That's the only way that the log with the same base could be equal on both sides. Okay, so 4n equals 3n plus 2, and then from there it's not so bad. We subtract 4n minus 3n is n, and n is equal to 2. It's always a good idea to check and see if we plug that in will we get anything negative, because that would cause a problem. But in neither case would it cause a negative, so n equals 2. There's no problem with that. Okay, this thing right here, same deal. We have the same base, so that means n squared plus 9 would be equal to this, and we may get something extraneous this time. Usually when you have an n squared, that's when that tends to happen. So let's put this in standard form by subtracting 11n and adding 1 to both sides. So when we get 0, we'll get n squared minus 11n, and then 9 plus 1 is 10. This can now factor what numbers multiply to 10 but add to a negative 11. They would both have to be negative, and it would be negative 10 and negative 1. So to make that 0, n would be 10 here and n would be 1 right here. Which of those would cause a problem? If you plug in 1 for both of these, there's no problem. And actually if you plug in 10 also, you get equivalence on both sides. So both 1 and 10 are solutions there. The problem would be if you plugged in either of those and got the log of something negative for either one. Then it would be extraneous. Alright, this involves using the properties of logarithms to, and the important part is we have to be able to do this without using a calculator. And the only way you can do that is by knowing these properties. So here are the properties. The log of two things multiply, that's like taking the log of the first number plus the log of the second. If you're dividing two numbers inside of a log, that's like taking the log of the first minus the log of the second. Finally, if you're taking the log of something raised to a power, you can take that power and just bump it in front right there. Okay, so we need to know that when we're solving these. So this one says the log base 8 of two numbers being divided. Remember, when we're dividing numbers, that's like taking this number here and subtracting the log of that number right there. So the log base 8 of 7, they tell us right here, that's 0.9, minus the log base 8 of 8. What number do you have to raise 8 to get 8? You have to raise it to the first power. So 0.9 minus 1 would be negative 0.1, or negative 0.1. That should be our answer, and there it is. Okay, right here, again, we're dividing, so that's the same as subtracting the log of the top number by the log of the bottom number. And here's the trouble. If you look at 36, 36 is not in the stuff that they're giving us, but they are giving us 6. And we need to be able to recognize that 36 is the same thing as 6 to the second power. It's the only way we're going to be able to solve that. Okay, then what it says is we could take this 2 and flip it in front. So we have the log base 5 of 1 minus 2 times the log base 5 of 6. You don't really need the parentheses there, but you can put it there regardless. Okay, anything, the log of 1 for any base is 0, okay, because anything to the 0 power equals 1. So this is like saying 5 raised to what power gives me 1? 5 to the 0. Minus 2 times the log of 6, and they tell us here the log of 6 is 1.1. So we're going to have 0 minus 2 times 1.1 is 2.2. So 0 minus that would be negative 2.2, and that is exactly the answer. Okay, here is, we're going to use the same properties, so these three properties right here are going to be used to solve these other problems. So here we have the log of two things being added, and we need to put that back together. So what did we do to the original log if now we're adding them? We must have started out by multiplying them. So we're going to multiply this thing here times this thing here. So x plus 10 times 5, and that's going to equal 2. Let's distribute the 5 right there. So we get the log. By the way, they're not telling us the base, so that means the base is 10. If they don't tell you, then assume that it's 10. 5 times x plus 10 would be 5x plus 50. It's equal to 2. Now we change this to exponent form. So 10 raised to the second power equals that. 10 to the second equals 5x plus 50. Whoops, that's supposed to be a 0 right there. And then 10 to the second is 100, so we will subtract 50 from both sides. 100 minus 50 would be 50. That's equal to 5x. We'll divide by 5, and we will end up with x equal to 10 as our final answer right there. X equals 10. You can always check by plugging it back in, but it will work. Alright, this one right here, same thing. Now we are subtracting logarithms. So what did we originally do if now we're subtracting them? Well, that means originally we must have been dividing them. So we do the log of this thing on the top divided by the log of this number. And that's going to equal the log base 6 of 3. And notice we have the same base here, so that means this expression must equal that expression. So x squared plus 2 over 9 is equal to 3. We want to get ultimately at the x squared, which means we have to first cancel out this division by 9. And we'll have to multiply by 9 over here as well. So we get x squared plus 2 is equal to 9 times 3 is 27. We'll subtract 2 from both sides. Get x squared equals 25. Then we'll square root both sides and put a plus or minus in front. That means x equals plus or minus 5, but my guess is that probably only one of these is going to work, because usually when you put in a negative 5 it doesn't work. But actually in this case they will both work, because if you plug in either positive or negative 5 here, you do get a positive. So both of those are solutions. So my guess was not right. So both 5 and negative 5 do work. The times when they wouldn't work is if you plugged it in, you got something negative as an answer. Or you're taking a log of something negative, I should say. Alright, for each of these we will expand out these logarithms right here. So remember, when you're taking the log of things being multiplied, that's the same as the log of the two individual numbers being added. So the natural log of u plus the natural log of v, and that is this one right here. Alright, this one's a little bit more tricky. So again, we're multiplying things. This is c to the 4th times that. So let's do ln c to the 4th. When you're expanding a multiplication, you end up what you end up doing is adding the logs together. So you have a times b. Let's take this and put it in front now according to that property that we've talked about before. So that's the same as 4 times the natural log of c. And then I'm going to write this one as you can do this, you can write this as the cube root of a times the cube root of b. And now we have another multiplication. So you can probably already tell from looking, actually not necessarily obvious which one it is from looking at it, although in some cases, yeah, in this case it is obvious, but let's pretend this is not multiple choice. We still want to know how to do it. So if you're multiplying these together, that's like adding the individual logs together. And then the cube root is the same as raising to the 1/3 power. So this is the same as a to the 1/3 plus ln of b to the 1/3. And then again, we can take these powers and we can move them in front. So we're going to get 4 times the natural log of c plus 1/3 natural log of a plus 1/3 natural log of b. And all that they did here was they just divided it by 3. That's the same as multiplying it by 1/3. So that's the same result. Alright, in this case we want to go the opposite way. So right there we expanded the logs. This time we're going to have to condense them, put them back. So here, this 2 out front, if you remember, we can take a power and swing it in front, or we can go backwards. We can put that on as a power. So that would be the log of x squared, which is right here. That's the same as taking this and swinging it in front. Okay, here we have a bunch of logs being added together. So that means we must have multiplied. Before we put them back together by multiplying, let's put this 6 in front. And then this right here, that's the same as the log base u times a half. So we can take that half and put in front also. So we have the log of v plus the log of w to the 6th plus the log of u, u to the 1/2 power, because that's the same as basically dividing it by 2 is raising it to the 1/2 power. What does it mean to raise it to the 1/2 power? It means to take the square root. So this is the same as the square root of u. And now, because we're adding these logs, we can put them back together as one thing being multiplied. So v times w to the 6th times the square root of u. That should be the answer. And it looks like it's that one right there. Alright, so that was up through section 7.5 and some of section 7.7 also with natural logs. In the next video, we will talk about 7.6.